I will offer my presentation in French, but beforehand, perhaps
Dr. Mollett, I just want to tip my hat to your presentation. You absolutely knocked it out of the park. That was stellar. So thanks for teeing that up.
I will, having seen the diversity within the audience, I chose to describe a pathway over 20 years on the discovery of not only, as Dr. Mollett was presenting, the particles which can be found in our environment and the origins of these particles. The caveat that I will mention very quickly is that even if I was born in Eastern Townships, I'm a Francophone, it's been 20 years that I've been working internationally, and my technical terms in French almost don't exist. So if I trip over a few words, please forgive me. And perhaps I will have to go and use a word in French to the left or to the right, but I will still try to advance forward in French. On this, I will share my screen. And once again, I will begin with a little introduction as to who we are and what we do. And following that, I will tell you a little bit in a personal context. I'll begin with the end to tell you that the theme and the subject of which we're discussing today is far from being new, and it's already very practiced in certain contexts. And what I tried to demonstrate is that this subject, in the large part, is approached either in universities or in certain governments, but very rarely, and certainly not enough, in commercial contexts, because there's simply no demand. And what I will show you here is the opposite. These are commercial examples that exist, and I will demonstrate a few secrets of how we managed to do these projects. So the standard that we developed is the reset. The slides are in English for our friends who are following in English. Our headquarters are in Quebec, and our second head office is in Asia, in Shanghai, simply because the project here the projects here are done 4 times faster, and it serves to accelerate. To put you in the context of standards which are more known through North America, when we take the current evolution of the green standards, these are standards that are very qualitative. So we always have a result which is gold, silver, platinum, qualitative results. The projects on which we are working are often very advanced. Clients tell us, well, it's been a few years that I'm gold, but I have no idea what this means. What is my health, my real health level? What are my carbon emissions? What is my circularity level? I want actual current numbers. I want real numbers. And so the reset standard was developed to respond to these questions, and was the first standard in the world developed in a quantitative manner. To show you a little bit the depth of the projects on which we're working, the towers, office towers, existing commercial buildings, mixed commercial centers. Here we see up all the way to universities here in architecture, especially on air quality that I'll demonstrate in a few moments. And in terms of interior projects, enormous amounts of retail, as we can see here, offices and hotels and etc. And so this gives you a perception of who touches these topics and how. I must say that over with more than 20 years of practice, all our projects are international. We've never done a certified project in Canada. Our first project, Canadian project, is with Brookfield, but not located in Canada. So the projects that I will be showing you are international, either in the US, in Europe, in China, in India, Australia, a little bit all over. The standard is divided in two or measured in two. On one side, the intrinsic impact on the materials. We often speak of the holistic effect on carbons, the materials connected to climate change, but we also we're introducing the concept of holistic impact on the health and materials. And when we do the embodied standard, the impact of materials on our health, it allows us to measure results in real time and continuous time via captors. So we have the operational standard, the aspect that is most known as the air quality, where we follow air quality in buildings. We take data at every minutes and a half, every minute, 3 minutes, continuously every day, and on energy also. But our theme today is air quality. So just to give you once again, and to ensure that you understand well the distinction and the difference that we're seeking to create within the industry, our green industry is really an industry that is qualitative. When we must choose a green product or a health product, we're struck by certification, such as what we see here. For the majority of people, this means absolutely nothing. So if I'm an architect or a consumer, we will choose the rug because it's better for the air quality and for my health. If I look at the little logos, it's impossible for a professional or even a consumer to know which is the best rug. I'll simply end up choosing which rug has the most logos. In terms of performance, what we are seeking is to find the performance level to be able to really compare the two and quantify and do sustainability accounting for health. And this allows us to compare materials not only on holistic carbon, intrinsic health, but also on health. And when we do the quantitative analysis of each material, we can assemble new projects to be able to quantify the intrinsic impact on health of the projects. All the data that we collect is treated by numbers. We must treat millions of data every day. So all of this is done in the cloud to facilitate the choice and comparisons of materials and to really be able to take decisions, quantitative decisions on the materials. The process finishes with data on, once again, circularity, carbon, but the theme today is health, where we can quantify the healthiness of a project, measure it, compare it to the health norm of buildings in the industry. So to give you a little context on what we do at this time, I'll return to 21 years ago behind. I was a graduated architect, where the idea was to go and get the most experience possible and not simply to go to the place in the world where we built the most projects, which was in Shanghai. I arrived in Shanghai in 2002. A young architect I did an enormous amount of projects, very interesting. First carbon neutral hotel in the world in 2007, enormous number of projects, modern styles, because we didn't find healthy materials. Simply, we cut all the materials that fit into architecture and just work with a structure, with healthy structure, because we weren't finding healthy materials. We simply eliminated them. The greatest structures in compacted earth in the world, projects such as this one, enormous amount of residential projects, which allowed me to do research in or for people in their homes. So to see cause and effect of the materials chosen and reactions of the inhabitants, and even to take devastated sites to transform them into eco-resorts. So an architect's pathway, which was quite interesting. We find ourselves in the media. It's good for the ego. It blows up our ego a little bit. And there's, of course, a certain hypocrisy which disturbs us, because as an architect, my personal background is in sciences, pure and applied sciences, background in chemistry and biology and physics. And by doing all of these green projects in a qualitative manner, we don't have data to really know if we're improving. Are we really doing green? So the questions we ask ourselves is, are we really making progress, or are we just getting better at making things look greener? As a young architect, we also realized that green building is an art. It's not a science, and it absolutely needs to be transformed as an industry. And we must bring science to the industry, which even today is more an art than a science in terms of health and performance. What causes us to push this theme? We always come back to the basics. This is my oldest daughter when she was 2 years old, and we began this research a few years before she was born, with a source of data, a data source which came to me at the end of the 90s when I was a student, that a child in Europe, in Northern Europe, by the age of 18, would have 700 foreign chemicals in their body mass by the age of 18. And so comparatively, compared to the number that we saw earlier with Dr. Godet in Canada, the zone here is in a zone of incineration of garbage of waste in Europe. So a higher quantity of chemicals. When we have a child, we say when our child is 18, they'll have 700 foreign chemicals in their body mass. It's very concerning. And I gave again this presentation over the years, and my children are growing. My oldest now is 17, and she's reaching 18, and it's always a number which doesn't leave their mind. Why? Because as Dr. Molat was demonstrating, the chemical products accumulate within the body. They don't leave us. It's very difficult to eliminate them. They affect the brain development, they affect the nervous system, and they particularly affect the lungs. So as an architect with a background in science, we want to know where all these chemical products originate from. And so we naturally think that the easiest place is food, what we're ingesting. But the reality is that we have more ease in knowing what ingredients can be found in a cookie box at $4 than in construction materials at $400,000. I buy $40 million in flooring for a project. I have no idea what is in the materials. And there we say, well, it's not really We're not comparing apples with apples. We're not going to eat the floor. We're not going to eat the construction material. But we realize quickly that, in fact, it's not true. We eat construction materials every day. And I'll show you how. So we begin doing analyses on the chemical products which are in the current materials. Here we see a polyurethane, which is very standard for a hardwood floor, what you have today in your home. What we see here, without going too much in detail, in red, are highly toxic products for either human reproduction, development, neurotoxicity. And so we see that just in polyurethane, a normal polyurethane floor, there is an enormous amount of products that we must avoid. When we speak about health inside, we speak almost exclusively of air quality. And as I mentioned at the beginning, we measure it in real time, 24 hours of 24. But of course, we began speaking in the early 2000s. We weren't speaking enough about solid particles. So we went and looked at dust. This is research done by an Italian researcher on carbons. We take dust, which can be found in a common house. We stain it to go and see the synthetic elements which can be found in the dust. And so what we see to the right, the colored elements are synthetic elements which are in dust. The reality is that dust in our homes is not natural dust. It is the world around us which is disintegrating. It's the carpets, it's the clothes, it's everything that we're using day to day, which becomes dust and which we breathe. And so once again, the toxicologists are asking, okay, these small pieces of material that come into our lungs through respiration, breathing, and which mix into water, we know very well that when chemistry becomes solid, and there is even deeper, more profound penetration. So what happens in chemically once it enters our lungs and becomes and mixes with water in the lungs? So all of this story, we find ourselves in 2005. In 2005, we do project after project. And I'll tell you honestly, we do green health projects. We choose certified COV products or less, but each of our projects are not passing. Each of our projects are failing. They're not managing the final COV tests or VOC tests. So once again, we wonder what is happening. We spend more money on healthy products, but the final result on the project is we're still above the quantity of VOC than we should be on. So how to calculate the emanations by product? The emissions of a chair, I have 8 chairs in a cubic square space. So I can simulate the concentration of a VOC before completing my construction. I'm in the norm. I complete the construction. I do a current test, and my results are at 10, 20, 30, 200 times what I had calculated beforehand. So there's a problem which is happening. We're not managing to find the problem. In 2005, we import green captors. These are very expensive for the simple reason to be able to start seeing in real time what was taking place. We absolutely were unable to understand why our results were always bad. We bring in air captors simply to follow the VOCs. What we see here is an example in 2005 of an apartment which was renovated 1 year earlier, where we open the doors every morning. So here you see 3 days. We open the window. It's very effective. This VOCs go outside. The particles, the external pollutants come in. But we see very quickly that the moment that we close the window, the VOCs grow back up again almost instantaneously what they were earlier, and it goes into the red. To return to Dr. Mollett's comments from earlier, the spike here is from hairspray use for setting the hair. So finally, we begin seeing or having visibility in real time in terms of what happens in terms of VOC, which emits materials, toxins 1 year after construction. What we also discover here is the table on the top, or the diagram on the top, which is PM10, particles at 10 microns. I'll admit to you, in 2005, I had no idea what a PM10 was. PM 10.5 didn't exist again. It existed, of course, but we weren't able to measure it in real time. So all we had was PM10. I had no idea what that was. We connect the captors. We see that it's a fixed line. So we say the capture is broken. We paid so much money for a capture. We don't know what it is, but it's broken. Until day 3, in this instance here, where we see the results from the capture beginning to appear, we realize the capture is not broken. The PM10 is so high that we're not even able to measure it. So what is the PM10? And that's where we begin to adventure into the wonderful world of dust. And we begin to understand the captures at $50,000, at $50, at $500 to try to compare the fidelity of the air captures. What we see here is a capture that we call grade A in our language, which measures 144 in terms of PM 2.5. A capture grade B, which is standard that we invented, which is at 139, which is relatively close, and a consumer grade capture, which we can purchase on Amazon, which is at 91. So instantaneously, we realize, okay, all the captures are not equal. And in 2010, more or less, we produced the first standard in the world for air captures, and to enable us ourselves to begin to understand what is taking place in the fidelity of the data, what fidelity we need in a world in a world of interiors. We do the first grading in the world for air monitors, RBC, how to begin to train professionals, to teach them how to install the monitors. And we develop analyses which allow us to compare the data through multiple buildings to ensure that everybody is doing calculations in the same manner. Otherwise, we cannot compare the final results. The result, the beginning of the reset standard, which, as I mentioned earlier, is the first standard in the world which measures air quality in real time and in continuous time. And this is not a slide from 2023. This is a slide which is already about 12 years old. And these are initiatives that we've been doing for a very long time already. After having written these standards, we began to see the first air monitors for architecture appearing on the commercial market, developed according to our standards. This one, for instance, which is a Swiss-Canadian air monitor for the interior, because we need to be able to compare air quality outside. As Dr. Mollett mentioned, when we increase ventilation, we bring external pollution, which is often more stronger, which just adds to the problem. So external monitors to be able to do the comparison, and the first monitors in the world to go inside commercial buildings. So in big mechanical systems to be able to do office towers, etc. So these didn't exist before we wrote the standards. And following this, we saw the companies beginning to produce monitors according to the standards. To give you an idea today, already after a decade, these monitors go into the mechanical systems where first of all, we go and get the air quality, external air quality. Following this, the air quality which comes out of mechanical systems before being polluted by people. So the air quality, which is given in this case in commercial offices. Following this, we'll measure the internal air quality because as human beings, we emanate VOCs. The clothes that we're wearing also have VOCs. So we need to know the difference between the air and how it's entered before it's contaminated by our human activities. Following this, the air that we're breathing, which is contaminated by our human activities. And again, normally I give very technical presentations. I'm trying to keep this a little bit lighter. But what we begin seeing, or what we were seeing before and what we're still seeing, is that the actual building standards do not work. The architecture is not conceived for the human. The human being should not be in commercial buildings or residential buildings, period. What we see here is a technique which is used everywhere. When we finalize a building, we do a flush out. We open the mechanical system completely. We open the windows. We push out all the VOCs, the pollution. Following this, we do an air quality test that we pass, of course, because everything is open. And we certify ourselves gold, platinum, and we enter into a green building. And when we do the measure of air quality, we see a whole other story. Right after having done the test, the VOCs begin to accumulate at nighttime when the mechanical system is closed. In this case, in the daytime, the mechanical system reopens, but we don't manage to return to the green, and it goes on over several days until the monitors are no longer able to read the VOCs within the building. The density has become too great. So this is what is really happening in a building after we've made a traditional certification test according to the norms available today, or the standards. Now we find ourselves in 2018. 2018, we begin to do research on liquid particles. Up to date, we were doing research on solid particles, but for X reasons, we begin to do research on liquid particles because when we sneeze, when we have a cold, we're sick in a space, liquid particles are projected at a distance and they remain suspended for a long time. The science behind contamination of the air and of viruses catching a cold finally through the air exists since the 60s. There's nothing new on this side. So we were looking more to apply this science to the data in real time that we were collecting. So
and applying it to the air monitors to see why some people are more sick during winter than in winter. And by noticing that it was because the quality of the air was dry and we were more prone to being ill because of the viruses that are attached to the liquid particles floating in the air. So that was 2018, 2019. 2020, COVID. And for us, for the people, it was a crisis on air quality. It was very significant. For all people living in Asia, it was the fourth crisis with regards to air quality. SARS-CoV-1, 2003, local air apocalypse in 2005, air apocalypse 1 and 2 in 2013, and now we've got SARS-CoV-2, 2020. That was the fifth, in fact, air quality crisis. And once again, then the systems were becoming multi-parameter monitoring systems, which allowed us to start to see and manage not only buildings on the levels of CO2, but also on the levels of COV particles, and manage the quality of air considering multiple parameters. And this, for what I'm showing you here, is a system in a school that has been installed. It's very visible, it's out in the open. When all the systems are automated and controlled by automatic air quality monitors that manage 5 parameters for air quality at the same time. This research allowed us to plunge and understand how exactly COVID was going to propagate, because we had already understood how exactly COVID was circulating in buildings, but how exactly it was going to propagate itself across the planet. So this is an article that we wrote. It's approximately exactly 3 years ago, saying that Canada would be the next area for COVID associated to the temperature and humidity levels. And it's by using these types of databases where all of and understanding where all this is at now, is that we had to analyze the transmission risk of the virus in real time with all of the data that I've been explaining since the beginning of my presentation. COV, temperature, humidity, etc. So to give you an idea of what's being done, currently speaking, across the world or the planet in terms of analysis, 24 hours a day in various buildings. So to conclude, in fact, in 2022, we step back and reach out to our roots to continue quantifying the quantity of chemical ingredients that are found in current architecture or modern architecture. And the figures that come of this, when we quantify this for the first time, and no one had ever done this before, by the way, the amount of chemical ingredients to the kilogram in current architecture, and the figures that we find, these are the real figures in certain projects I can't mention, but the averages is between 2 and 8 kilograms of contaminants, red listed contaminants that can be found in any project. And it's completely hallucinating. I mean, it's completely mind-blowing, these figures. You know, I come in to your house and I come in with a whole teaspoon of cancerous products and just dump it into the air of your house. And so it's incredible. And where do these contaminants come from? They come from certain certifications that we use today. For example, one of them that's most well known for green housing. There's exceptions for the ingredients that are found, for example, in this one here, in the flame retardant percentages. But when we accumulate all those exceptions, we find ourselves with, nonetheless, in this one here, 175 grams of red listed chemicals per meter square, which is insane. Now, with regards to the information provided to clients or the people that we work with, is found in a laboratory. The techniques could be adjusted up to 100 ppms, and when we're calculating chemical products. Now, I want to conclude here. I want to mention that we're often asked, how many clients pay for this kind of service, that approach us and want to know more about health in the buildings? And the amount is 0. And the approach that we need to take is that we have to say, the hot topic right now of today's world is carbon, intrinsic carbon. And we are often asked to do new carbon neutral buildings, build them, but we say no problem. But to do so, we need to build a healthy building, because if there are ingredients in the building that are toxic or bad for our health, nobody's going to want to recycle the materials. And if we don't recycle the materials, so the carbon footprint rises, and it's important to do a carbon neutral building without looking at health. So currently speaking, we are at the step of creating projects like this one for clients who prioritize this approach. And the most advanced is 82% of the red list known chemicals or ingredients, and targeting 94% of red list free ingredients. These are approaches that are possible today and that are being done. And once again, for a healthy approach that is generated via the demand for carbon neutral buildings. So once again, being asked these things, or to have to create buildings that are healthy. It's not something that's necessarily very common or in demand now. But to make science move forward, we need to use other means to have it be well known and to have it be demanded or being made available. So why put so much effort on a theme where there is very little demand? Well, it always comes back to the end, to the same thing. It's for our kids. And there's a picture last week that really affected me, so I decided to put it in my PowerPoint presentation to conclude. To me, this is a redefinition of success, where the government signed free lunches for kids in his state, Minnesota, and this is the thanks he got. So as we were saying at the very beginning, it is a responsibility. It is research that is needed, that needs to be done, and it is the type of compensation that we should be able to find at the end of all the work being done. So I conclude on this. Thank you very much. Thank you for listening. If you wish to hear our evolution, we're very present on LinkedIn, and I will conclude on that. So once again, thank you for listening. Thank you again.